Hi, welcome to our next level 1 chance and data video. We're going to talk about experimental probability. When we conduct a mathematical experiment, we can use the results of the experiment to estimate the probability of an event occurring. In the last video, we chatted about theoretical probability, which is the probability calculated based on the theory of what should happen if an experiment was to be conducted. The theory of throwing a die should be 1 chance out of 6 for each number. However, when we do the experiment, we can use experimental probability, which is the probability calculated based on what actually happens in the experiment. Experimental probability is often called long-run relative frequency or just relative frequency. All right, first example, die is rolled 6 times. The theory says we should get an equal chance of each number, so we should get 1 of each. However, after I've conducted this experiment, you can see my results. And you can see I got no 1s and I got 2 5s. So here are my relative frequency or my experimental probabilities. The probability of getting the number 1 was 0 chances out of 6 because I got none. But the probability of getting a 5 was 2 chances out of 6 because I got 2 5s. What if I was to roll the die 600 times? Well, the theory again says this is an equally likely chance of happening, so we should get 100 of each number. But after performing my experiment, you can see that I don't get 100 of each number, and I get these long-run relative frequency results. I did call it long-run relative frequency because after 600 rolls, you probably sit down for quite a long time. What about if I flipped a coin 20 times? Well, again, the theory says I should get equally likely chance of each, so I should get 10 heads and 10 tails. But once again, when I do my experiment, I find that I don't often get 10 of each, and in this experiment, I happen to get 6 out of 20 heads and 14 out of 20 tails, as my relative frequency results show. Right, well, here's a different application. Tina is a striker in a football team. So far, she has played 12 games in the season, and here's a summary of the goals she's scored. So can you see that she scored no goals in 6 games? She scored 1 goal in 3 games. She scored 2 goals in 2 games, and she scored 4 goals in 1 game. So here are my relative frequency probabilities. I don't have any theory to base this on, so I can't use theoretical probability to work out what's the probability of her scoring 3 goals or 1 goal or no goals. So I'm going to use this experiment of the first 12 games to work out her experimental probabilities, which we call relative frequency. Right, finally here is a graph that represents the probability of getting ahead after I flipped a coin 100 times. So on the x-axis I have the trials, and that goes all the way up to 100 trials. So I flip the coin 100 times. On the y-axis I have the probability of getting ahead, and I'll put it on my scale, probability scale of 0 to 1, which 0% up to 100%. This blue line down the middle represents the theory, what should happen 50% of the time I should get ahead. What you'll see is the first 3 throws I got head, head and head, so it stayed at 100% head. But afterwards I started to get a few tails and the probability of head started to drop. It was about here where I got to 50%. After about 22 flips I got to my 50%, but then I dropped below 50% for a short time. It continues on. At this stage, between 50 and 60 or 70 rolls, my probability of getting ahead drops well below, well, not well below, but a little bit below 50%. But in the end, you can see after a long time, which is why we call it long run relative frequency, after a long time, it starts to get very close to the theory. So the experimental probability starts to come close to the theory. Right, well, that's our second video. Thanks so much for tuning in.